So, good morning, and today's lesson is on simplifying algebraic expressions. Oh, and good morning, Brittany. Oh, nice picture. Look at all those lovely, lovely ladies. Okay, so I'm just going to work some of these problems. And Brittany, I bet it was you logging in that reminded me to start recording, because
don't forget.
No, I pushed the button just as your picture popped up on the screen. So we're thinking alike. Share. Okay, so this book here is written specifically for the GED test. And when you take your GED Ready test, which is the official GED practice test, it will give you a score, and then it will also give you a list of pages out of this book that you should study in order to improve your score. So we'll work a few of these. Okay, the number of miles between Elizabeth's house and her grandparents' house is 3 times the number of miles between her house and her older brother's apartment. Elizabeth's brother's apartment is 39 miles away from the house. How far away is her grandparents' house? Okay. So here I am with a picture. Here we have Elizabeth, here we have brother, and here we have grandparents. And it tells us that Elizabeth is 39 miles away from her brother. So we have distance here is 39. And then how far away from her house is her grandparents? Wait a minute. If the grandparents' apartment is 3 times the number of miles between her house and her older brother's apartment. Okay, so yeah. So here's 1 times. There's 2 times. There's 3 times. So with a picture like this, I think I can figure out what the answer, how many miles it would be. That's what the question's going to be, though. Yeah, it is.
117.
Okay, I like 117. So you just took 39 and multiplied it by 3. Here's an expression. And I can call it an expression because it's made up of numbers, variables, operators. Represents the distance between Elizabeth's house and her grandparents' house. X equals 12, Y equals 3. What is the distance from Elizabeth's house to her grandparents' house? This time we just get to put in 12 for X and 3 for Y. And I put parentheses around here to mean multiply, because this means multiply. Okay, so this is a different distance. It's a different setup, and we get a different answer than we did up here.
Yeah.
What did you get?
I got 1.
Say again. Did you get 21?
Did you divide by 5?
Yeah, I did divide by 5. So I took 9 times 12, then I subtracted 3, and then divided by 5. 9 times 12. Yeah. And when I do that, I get 21. There. See what else they have. Notice that just glancing at the page, these are all word problems. And that's what the test looks like. So, okay, number of girls that registered to play basketball in a summer league is 15 fewer than twice the number of boys. If B is the number of boys, which expression describes the number of girls? Okay. I have to think about it first before I let myself look at the answers. We know B is boys. And girls is 15 fewer than twice the number of boys. So I can do that. Girls is going to be 15 fewer means I'm going to have to subtract 15. And I'm subtracting it from twice the number of boys. Boys. Okay. Which expression describes the number of girls? Let's see if anything looks. Oh, yay. I always like it when one of the answers comes up to be like mine. Doesn't necessarily mean I got the right one, but oh, I'm not even going to do that one. This makes me crazy. I remember it from last time. I'm just going to skip it. You don't want me to be crazy today. Edward drove 4 times as many miles on Tuesday as he did on Wednesday and Thursday combined. The expression describes the number of miles he drove on Tuesday in terms of the number of miles he drove on Wednesday and on Thursday. Oh, man. Okay, so it looks to me like Tuesday is going to be compared to Wednesday and Thursday, but we're going to have to add up Wednesday and Thursday.
So do you use those as an expression, like T and W?
Personally, I would use W for Wednesday, and I would use TH for Thursday, and I would use 2 for Tuesday. However, the question is specifically telling us to use X for Wednesday and Y for Thursday. So without even looking at the answers, I bet that X and Y are going to be in the answers. And if I have my answers as Tuesday and Thursday, I won't be able to deal. Mm-hmm. So Wednesday and Thursday, I'm going to add them up. Here's Wednesday plus Thursday. But he went 4 times as many miles on these two combined. So we're going to have to combine them or add them up and then multiply them by 4. Let's see. Oh, there we go again. I love it when my answer shows up. So 4 times combining Wednesday and Thursday. Okay. I don't mind this one. This one challenges, but it's not painful. So I can get it to focus. It doesn't like to focus when I have a book involved. Okay, that's better. A museum Admission fee for a child is $4 more than half the admission fee for an adult. Which expression describes the amount paid for 12 children and 4 adults to visit the museum? Oh my gosh, we're going to have to do a couple things here, I'm sure. Okay, so first of all, an adult, we're going to say that's an adult. And child is going to be 4 more than half the admission fee for the adult. So I know I'm going to have to add 4 to it. It's only going to be half of the admission fee for an adult. So let's have the adult 2. Okay, now we want to get 12 children and 4 adults. Let's look at the answers and see what we're going to get here. Oh, look at, none of the answers have child in there at all. Notice that they're all about adults. So, but when we express child like this, we say that we're expressing it in terms of adult, which means that we're just using adult as the variable and doing the stuff to that adult variable we have to do to make it equal the child. Okay, we wanted 4 adults and 12 children. So if we'll have to have 12 of these things. Here's 1 child, and we need 12 of those. This looks terrible, doesn't it? And we need 4 adults. This looks to me like we need to do a little distributive property on it, because this can definitely be simplified. All of these answers look way too slick compared to this. Okay. So here, if we distribute this 12 times A over 2, oh my gosh. Well, let me write it down. 12 times A over 2. And we're going to add to that 12 times 4 is 48. And then 4 times A. This can be simplified because 12 divided by 2 is just 6. So I have 6A plus 48 plus 4A. Ooh, this is starting to look better, and this is definitely easier than that mess. And now we can combine the terms that are multiplied by A. So 4 A's and 6 A's and 4 more A's makes 10 A's all together.
Let's see.
Look at that. Would you have ever just guessed that? I know I wouldn't have.
God, that was a pain in the ass.
Yes, it was, wasn't it?
Yeah.
Boy, just wait till you get good at these and you can see.
Gosh, I just need to get, yeah, I need to do a lot of those. I mean, it makes sense. It's just hard.
It's fun to watch somebody else do the work. Okay, this one, for most people, this is going to be just as complex. Except since we have a real life picture to go with it, it's easier to make sense of what's going on. So this question is asking you 2 things at once. It's asking you, do you know the definition of perimeter? And then can you simplify all this stuff? So we haven't had geometry lessons yet, but perimeter just means the distance on the outside, all the way around the outside.
Is it Is it a B or C? That's my guess.
And what is it about D that you dislike?
They didn't add any of the like terms.
Yeah.
Okay. Oh, okay. So you just looked at this and added up the like terms?
B.
Wow.
There's 2, 3, 4, 5. There's 6 of them. Okay. So it's got to be between these two. Right?
I think it's C.
Okay. I'm going to show you a trick for this. Perimeter definitely adds up all the sides. If you ever get one like this, here's how I solve it. Here's G plus 1. And here's B. I'm going to put that right here because I can just add, I'll be able to add it easily. And then here's -4 plus 3B. I'm going to put the -4 there and the 3B there. And I just organized it this way so that I can add up the B's easily and I can add up the constants easily. So I have 6 B's and this adds up to -3. So, good for you for recognizing right away. It at least had to be one of those two. I'm skipping over some of the worst ones here. Number of students in an incoming freshman class is 3 times the number of students in the sophomore class divided by 4. Which of them, the blah, 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 the incoming freshman class. Okay. Freshman is going to equal 3 times the number of students divided by 4. That, I don't know, that just seems completely straightforward to me. Did that seem easy to you guys? Now, are in any one of those that has an S in it? Do we care?
Nope.
No, we don't care. This one looks just like this one right there. Except they used a different symbol for the unknown. Expression 3 times the quantity x plus 2x represents the distance between 2 cities. What is the distance if x equals 4? Oh, we can do this one. To put 4 in every time you see x. Oh my gosh, look at all those parentheses I ended up with.
Why did you parenthesize the 4 on the right?
This
What?
one?
It's just times. Yeah, it's just times.
Yeah, it's 2 times 4. But
Just
this,
to help you or what?
yeah, I could have gone like this.
I usually just put a dot, but that's just me.
Yeah, you know, a dot is okay too. I don't like using words. If I do 2x4, we can't tell if that's a variable or an operator. Many people do use a dot.
Yeah.
But if you ever write that dot just a little bit too low, now it looks like it's 2.4 instead of 2 times 4.
Oh, yeah, yeah.
So I did it like this. And then I have to use that one to close this.
12 times 3.
Right. Now, we could use the distributive property here. That would be extra work. I'm just going to do this. 2 times 4 is 8. 8 times 4 is 12. 3 times 12 is 36.
There it
Yay.
is.
There it is. Oh, it feels good to get an easy one once in a while. And there are some easy questions on the test.
Yeah, I like the parentheses, especially if there's like a negative, because if you're just inputting it on the calculator, you want to put it exactly how you see it.
Yes, you do. That's a very good rule to follow. Okay, here's an expression 15A plus 25B, and it represents the amount of money a theater takes per night if they sell $15 seats, sell A, $15 seats, and B, $25 seats. I can see how this would be horribly confusing, because someone might think that they're going to sell a $15 seat. But no, this means an unknown number of $15 seats and a different unknown number of $25 seats. How much money does the theater take in if A equals 207 and B equals 134? Oh, this is the same thing. 15, we just have to fill in the numbers, times 207, filling it in right there, plus 25 times 134. Ooh, I want this business. Ooh, yeah. I definitely want this business. Did you get that big number?
Yep. 6,455 bones.
Yes, I got that.
Wouldn't you love to count $6,000 every day at the end of the night?
I used to have to do it.
What'd you say, Billy?
I said back in my day, I used to do it.
Oh, that's cool, isn't it? Yeah,
Yeah, I'm not.
like
not
that.
like that.
We could all make a drive-in theater.
Have you ever counted 50,000 in 20s?
It's hard not to make a mistake, isn't it?
I'm pretty good at it, but yeah, it definitely start hurting your fingers after a while.
Let me ask you this. If you're counting, you're like counting in 20s, right? So you're like 40,880, 40,900, 40,920, 40,000.
So
You
I
put it
do
in
it.
piles?
I do it by 1, 2, 3, 4, 5, 6, 7, 8, and I just count how many I have.
Oh, okay. And then you have to multiply it by 20, right?
Yeah, so 5 20s is 100. So yeah,
Yep.
easy.
Right. Let's do this one. Okay. The length of a rectangle is 3 less than 3 times its width. If W is the width, which represents the area? Say the length is 3 less than 3 times. Do you agree that that's the length?
Yes.
But it's not asking us what the length is, it's asking for the area. And you will have the formula sheet with you. Area of a rectangle is length times width.
Yeah. You just remember that. I just remember that.
Well, yeah, most of us have that one memorized.
Yeah.
We're going to need to multiply the length times the width. Okay.
9.
And actually, I multiplied the width times the length. The reason why you can switch the order when you multiply. And the reason why I switched the order is because it's easy for me to see now that in order to do anything with this, I'm going to have to use the distributive property. Let's look at the answers and see what form they want it in. Ooh. Oh my goodness. Thank goodness.
Yeah, thank God it's not C or D or B.
It is C. Look, that's exactly what we have here.
Oh, it is. Look at that.
They didn't make us do the distributive property. So I can say that this expression is not completely simplified. But that compares to what we
You could get B and A mixed up though, because if you didn't add the, oh, it's missing.
Yeah. A is just the expression for the length. And they do that a lot. They have in the choices for answers, a lot of times they will have some sort of an intermediate result, something that you need to calculate before you can continue with the problem. Don't let them trick you with that. Yeah, we'll do this one. Number of minutes that Erin spent on project A is 45 less than 1/2 of her time spent on project B. Okay, so that 40, every time that I've been working these, when I see a 45 less or a 15 less, you've seen me write that down first. Okay, so 45 less. I write that down first. Oh, wait, you can't see. That's because yeah. Okay, here we go. All right, there's the 45 less. I know that's going to be part of my answer. And I can look at these and I know it ain't A and it ain't C because we're going to have 45 less in there. And then it's less than 1/2 of her time spent on project B. So here's time. And if I want 1/2 the time.
Yep.
Okay, so does one of them look, oh, look that, oh, that one looks the closest. And I guess this is something that a lot of people are just really used to. But dividing by 2 is the same as taking 1/2 of it. 1/2 of it is the same as dividing it by 2. And Monday, the cyclist rode 20 fewer than 3 times. 20 fewer than 3 times the miles rode on Sunday. I'll use S for Sunday. If he rode 30 miles on Sunday. Oh, I get to put the 30 miles right in there. Um, 3 times 30 is 90. Subtract 20 should come out to about 7. These kind of word problems, in some ways, they just make me angry. I like word problems that represent real life situations. This is
Me too.
they just made this up to be complicated and to say it in words so they can call it a word problem. Okay, we have Leo and his sister, and Leo is 21 less than 2 times the age of his sister. Man, these are all kind of seeming the same to me now. Are they feeling familiar? Okay, now the sister's 23, put the 23 in there. 2 times 23, subtract 21. It's gonna be out to 25.
Fine.
Oh, I'm typing all this stuff in. I haven't turned the calculator on. Did it come out to 25? 46 minus 2.
Yes.
Yeah, 25. 25. Let's see if I can find something different. Ooh. What does this say? I can't even read this. If negative 3, 5x, then what? There's something missing in this problem, isn't there?
Commas.
Does it need to have an equal sign or something? Oh, well, we're going to skip that one because we wouldn't be able to guess what they want. The good news is the GED actual test has been taken so many times that if there's any boo-boos in the GED test like this, like where there's stuff missing, they've already found it. They fixed it by now. Let's see what, these are kind of here. Let's use this one. This one is very different from all the other problems on here. It says rewrite the expression in terms of x, assuming y equals 2x. Oh, what a big mess. Gosh. I guess I can think of a couple different ways to approach this. And I don't believe I've worked this problem previously. So I'm just gonna attempt it. And if I don't like the way I'm working it, I'll start over the other way that's possible. Okay, so this is saying that y equals 2 times x, and it makes sense to substitute 2x into this equation every place where there's a y. So I'm going to do that here. This now has to be 2x. Wow. I don't know how many of you are comfortable with canceling things out when you have fractions. But what I have here so far, this thing is division. And but it makes a fraction. And here I have an x on the top and an x on the bottom. Oh, I don't want to do that. I'm not going to do that. I'm just going to go ahead with a different method of working it. This needs to be, I need to use the distributive property here. So 2x times x is going to be 2x squared. I'll have to add. 2x times 4 is 8x. think this is going to make a big mess that I'm going to be sorry. X times 2x is 2x squared. X times 4 is 8. Oh yeah, I'm really sorry that I did this. What I've written here is absolutely true. I haven't made any mistakes. But I haven't gotten closer to an answer. So I'm sorry I did this. And I'm going to go back to, see, I'm looking at, look at their answers. They're so much easier. Yeah, I know what I want to do here. What should I do at this point? I'm going to go back to the very beginning here. We'll try this. I'm going to distribute first. Y times X is YX plus Y times 4 is 4Y. X times Y is XY. X times 4 is 4X. I don't think I'm going to like this either. Now I'm going to substitute. Anytime I have a Y, I'm going to change it into a 2X. Change that to 2X. There's a Y. I'm not liking this either. Nope, I don't like that either.
If you had an X and an X, would you square it if you had?
Yeah, you do. What I'm not liking about this is that I'm doing all this stuff and I'm going to have to go backwards and undo it.
Mhm.
Don't you love it when the teacher is stumped? If I go back to here where I substituted 2x in every place where there was a y, I can cancel these x's out here because this is all multiplication. This is multiplication. I have an x in the top and the bottom. Then it gets really simple after that. Because when I distribute, it's 2 times x is 2x plus 2 times 4 is 8. Oh, no. We still, I don't know, maybe there's no way. I think there's no way to avoid factoring in this point, what I'm seeing here. I can still simplify all of this because both of these, that puts it back to where it was. Can I work this one later when I'm not on camera and then come back with, I'd like, I know I can solve this. I'd like to solve it in a way that I can show you and have it make sense to you. So I'm just going to put that one on hold. Let's finish this off with an easier one. Let's do this one right here, right below it. This one is easier because it's asking, here we go, evaluate. It's asking to put in a number and do the stuff to it. Good morning, Vicki. So we want X to be 2 and Y to be -1. And this is going to give us good practice on squaring a negative number, which if you square anytime you're going to raise a negative number to a power, put that negative number in parentheses. Okay, so we want it to be 2 squared, subtract -1 squared, 2 squared, subtract, add 1, -1 squared. I can put it into the calculator just like this, which really scares me. There's so much stuff in there. It'd be really easy to leave something out. Or I know that 2 squared means 2 times 2, so that equals 4. -1 times -1 is +1. 2 squared again is 4. This is +1, so it's going to be +1. So this whole mess simplifies to 3/5. Did anybody try putting it into the calculator? This whole thing into the calculator? Like that?
No, maestra. No.
If we do it correctly, we'll get the same answer here. I don't know. I'm going to see if I can do it. Just want to try to do it. Okay, so it's going to be a fraction. Whoops, let's get this completely clicked. Fraction key. I'm going to put 2 squared. And I'm going to subtract -1 squared. Oh my gosh. And on the bottom, I'll have 2 squared. Add -1 squared. That didn't come out to be so bad, did it?
No.
Yay! All right. All right, 3/5. We can do it. We definitely can. Okay. All right, so I have a collection of problems out of the other book, the book the companion book. This is the one we worked out of today, and this is the companion book. Same publisher and same kinds of problems. I have some practice problems out of this book that I would be very happy to send anyone who would like these kinds of problems to practice.
I want to.
Okay. And Joe, do you want some of these to practice?
Yeah.
Okay. Because they weren't too easy for you, were they?
No, that last one, that 2x and the y substitute was definitely complicated.
Yeah, I have to think about that one for a minute. Okay, anybody else want? Okay, now there are also problems like this in your KET lessons. Oh, let's take a minute and look at those. Which would Oh no, that doesn't sound good when it's doing that. Share. Go to step. So we've been working on simplifying and writing expressions. And we also evaluated some expressions. So evaluate is when we put a number, substitute a number in for the variable and do all the arithmetic to it. So let's look at this one. I just have a nice picture on that first page. And when I'm showing you things in these lessons, it's not meant to replace spending time to read about it if you need to. I've already read this stuff, so it's easy for me to skip over it. Oh, okay. I'm looking for some examples here. Next. And here we go. Which expression does this drawing represent? What's your guess, Billy?
C.
Yeah, I like that because there's 5 Y's and 3 X's. Okay, 8M subtract 2M. Yeah, it looks.
Yeah.
Yeah, it looks like B. Okay, here we go. Terms are considered like terms when they have the same variables raised to the same power. That was really hard not to take that call. And we talked about this yesterday. So if it's a number multiplied by the same variable, it's going to be like another term, same variable. And the variable has to be raised to the same power or not raised to a power. Oh, I like this picture. So if you have a variable that's not raised to a power, it's representing, you can think about it as representing distance on a number line. If it's squared, you can think of it as a square. And like if we have 5 squared, that means that this length would be 5 and this length would be 5. And if we're talking about the area of a square, which is a 5 by 5, you know, for area of a square, 5 times 5 is 25. And x squared, if x is 5, it's 25. When you have an exponent of 3 on something, that means that it has 3 dimensions. So it can't be a flat square anymore. It has to be a cube. And we even pronounce this thing as x cubed. So the shapes are different. They cannot be combined. Simplify. So, we can combine the 6x with the subtract 2x and come out with 4x's. A is the only one that has that first term correct. Let's see if the rest are correct. I see 5y's plus 5 more y's, 10.
Distinct wise.
And I see -7 and plus
Plus positive.
-3.
-3.
Okay. Okay, so this just complicates things a little bit because there are some x's, some x squareds, some y's, and some y squareds. Can't combine the x squareds with the y squareds. How many x squareds do we have? Let's see, 12 here and 3 here. 15. Let's see if the rest of them come out right. -3x. Because there's no other x terms. And then the y's, 2 of those. This one that's 1, so there's 3 y squared altogether.
-2y.
Okay, so that's the one right there. Billy, these aren't too bad, are they?
No, not at all.
Not at all. Yay. Okay.
My girlfriend gets on me to write it out fully. She always writes them out all the way, and she always yells at me to write it out.
Oh, does she? Well, I can say this.
It helps.
It does. When you get into even higher mathematics, or even some of these problems that we're going to be working, where you end up with lots and lots of steps, if you write it down, at least you can go back and see what you did. If you don't write it down, you kind of just have to start over if you don't like where you are. Okay, so this looks like we're going to do some distributive property. A times B plus A times C. Blah, blah, blah. There's a video to go with it that will help you better than my videos. Expand and factor. So let's look at this. So this is what I was trying to do with that last problem number 27, which is going to drive me crazy till I solve it. The command here is to factor. So what we're going to do is look for some number that divides evenly into both of these terms. So we have a 3 and a 6. I know that 3 divides into both of those. Okay. The other thing is that both of these terms have x in it. This has plain old x, and this has x times x. So we can actually factor out the 3 and an x. If you take 3x squared y and divide it by 3 times x, what you have left is an x times y. If you take 6x and divide it by 3x, you end up with 2. So here's the 3x that we factored out. There's the xy that's left from this term. And here's the 2 that's left from that term. Oh my gosh. So when we write it this way, it's called the factored way. When we write it this way, it's called simplified. Ooh. Oh, look what they're doing to us. Oh my gosh. I know I can do this one. If they're telling us to simplify, we're not factoring. We're going to use the distributive property and then combine like terms. So we're going to have to do the distributive property in both of those terms. 4a times 2a is 8a squared. And we'll have to subtract 4a times b is 4ab. Now, this other one, I'm hesitating because I'm not sure what's the easiest way to teach this. I'm going to teach it that subtract a half b times 4a minus 4b. That subtract 1/2 b is what we're going to multiply both things by in the parentheses. And you have to keep the sign with the 1/2. So we're going to take negative 1/2 b and multiply that by 4a. Negative 1/2 times 4 is going to be 2. So we have negative 2, and then we still have a times b. Oh, what a mess. And then we're going to subtract. Negative 1/2 times 4 is 2. Negative 2. Oh, what a mess. And then b squared. Oh my goodness. So, what can we combine? I wrote all that stuff down while I was speaking. I ended up with an 8a squared. So I know that answer A is wrong. I ended up with negative 4ab, negative 2ab. So there's negative 6ab's altogether. And then I have subtract negative 2b squared. Subtract negative is like adding a positive. Oh my gosh. Should we see if I can guess correctly? Okay, so that one, the math isn't terribly hard, but there were just a lot of steps in it. Great, great. This is a good level for most of you to be practicing. Okay, this one, factor. Start with that 12x squared y and the 6xy. We're looking for which variables are they both multiplied by and which number can they both be divided by. 12 and 6 can both be divided by 6. So I know we can factor out a 6. And then on that first term, the x squared y, that's x times y. So it has an xy in it, and the 6xy has xy in it. So we can factor out an xy out of both of those terms. So altogether, we can factor out a 6, an x, and a y. So I'm going to choose between A and D. Which one do you guess it is, A or D? Who's guessing D? Let me bring up my camera and show you how to do this. So this is what we were asked to factor, and this is how I factored it, because both of these can be divided by 6, and both of these can be divided by xy. When we divide out 2xy out of this, what's left, sorry, when we divide 6xy out of it, it leaves us 2x. And this thing, when I divide this by 6xy, any number divided by itself equals 1. And we could check to see if this thing, if we can make this thing go back to that by taking this times the first thing. So 6xy times 2x is going to be 12x squared y. And we add 1 times this is just 6xy. So this 1 here is actually a very important part of the answer.
And that's because what was A showing? A was showing the 1. Okay.
Say your question again.
Oh,
Oh,
I was
A, yeah. A doesn't have that +1. So it just completely leaves out this part of it. This one is correct. Now, I can say this for sure about this lesson, this particular one that we're working on now. It's going to be easier if you've completed 2.1 and 2.2 and, you know, really spent some time with them. Okay, and then this part, evaluate by substitution. That, for most students, that's easy to do. If you've got a calculator, you just put the numbers in. So I think I'd like to. Oh, and you know what? When I click on it, it did. It let me go there. Okay. So I just kind of skipped. Right expressions. Okay, here's what we were doing. Oh my gosh. 3 friends decide to split the cost of joining a video game rental club. The club is $9 plus $5 for each game rented. Write an expression. Oh, okay. So the friends need to add the monthly charge, which is the $9, and then $5 per game. And then they're going to split it between 3 of them. So they get to divide that amount by 3. I'm going to let you guys puzzle on this one for a minute. Ah.
So the only one I'm seeing with split in it is D.
No, I like that, and I like the way you express that. That's the only one that I see a split in it also. Here they're going to split them up. They're going to divide them in half. And let's see if it likes it too. Yeah. Oh, good job. Yeah. And when I'm working problems with you, I cover up the answers. I don't even let you see the answers. I work it all out and get my own answer before I look at the answers.
Mhm.
That's
I was going with A
I'm not
before.
necessarily advocating that as a test strategy. I think it's great to look through the answers and see if you can find some hints in there to help you solve the problem. And that was a great hint saying, oh, there's only one of them that splits it. Saves a lot of work. Billy, do you see any here that you like? Who else is on? I keep picking on Billy because screen is at the top of my list.
C.
Yes, yes, that's perfect. Good for you.
Like, yeah.
And with a problem like this, when you're puzzling it out, it's perfectly okay to think about a specific number of miles. So like with this, you know, if she rode, or kilometers, if she went 2 kilometers, you know you'd have to go 25 times 2, and then you'd add in the 125. And this is the only one that's going to give you the same answer as what you would get if you just were thinking about a specific number of kilometers. Right. Cool. And it looks like that's it for lesson 2.3. So there were, if you go back and work all these problems, then it will give you an option to choose a review set of questions that are all on this same topic. And that would be a good way to get some extra practice, right? I'm going to stop. Okay. So I want to make sure that everybody knows that we have class tomorrow. Yes? Right?
Yes.
Yeah.
Yeah.
Man, it's hard for me to work on Fridays. I haven't had to work on Friday for 7 years. So.
I love that. I had to get stitches out of my arm, and I was sitting there, and the nurse was having the hardest time where I ended up getting all the stitches out by myself.
Did you really?
She was not that steady-handed.
Hey, Mary,
Isn't that interesting?
thank you for working Fridays for us.
Oh, you're welcome. You're welcome. That makes it all worthwhile. Really does. Yeah. So, Joe, I want to know more about the stitches. So you pulled them out yourself?
Yeah. I go to the Nashville Health Clinic, and the first lady was like, "Oh, maybe we should soak it," and I was like, "Well," because she was confused because I actually got them in Durango at the ER, and so they weren't aware how they stitched it, and they like went under a big chunk of the stitches, so I had to like pull it out. It was like a roller coaster, basically, like getting it out because it was all swirled.
Oh, cool.
But yeah,
I personally, I just think stitches are so cool.
that was actually my first time getting stitches in my life. Surprise me.
I've only had a couple of stitches. And I like taking them out myself. When they're ready to come out, they itch and stuff. Oh, I like to get those things out.
You were,
And when they're ready to come out, they come out pretty easily. If you let them keep them in there too long, then it's kind of hard to tug them out.
Yeah, that was my issue. They said 8 to 12 days, and on 8 days it was healing pretty good. So,
You went in.
and my girlfriend was like, "Well, you need to go because they're gonna take it out so it doesn't scar." And then when I get there, I'm like, "Oh, it's not Grey's Anatomy."
No, it's not. It's not. The other thing that I think is really cool are staples. Man,
Oh.
those are really cool because they don't stick as much. They look nasty, but they come out really easily.
Mary,
Yes.
why did you get beat up all like so much? You've
Why-
had staples, you've had stitches. What else have you had? Did you break your arms and stuff?
No. The worst injury that I've ever had. Yeah. The worst injury I ever had is I was hiking one time and I slipped and fell on a rock that was sticking straight up, and it hit me right in the breastbone, and it caused 3 of my ribs to separate from my breastbone, and it hurt. It hurt. And it took and there's nothing they can do for a separated rib. What they tell you to do is make sure that you take some deep, deep breaths every day. Because when your ribs hurt, you tend not to breathe deeply, and you can get pneumonia just from not clearing out your lungs. You just have to wait for ribs to heal. I've just had a couple of little boo-boos. I had one time I was holding a bottle of juice in the parking lot, and it was glass, and I dropped it, and I tried to grab it before it hit the ground, but I grabbed it as it hit the ground and broke, and so it sliced up my finger, and I had to have 3 stitches in my finger. That's my second worst injury that I've ever had in my life. Never broken a bone. I guess that's just kind of weird considering some of the stuff that I have done. I like medicine. I worked as a medical assistant for a few years, and I like all that stuff. Like, I think blood is a really cool. It's just an amazing thing that is a part of our life. It doesn't gross me out or anything. I have a great respect for it. And so anyway, tomorrow we'll have class. We'll have a short lesson, and then I'll give you an opportunity to work a practice test while I'm right here on the other end of your computer. So you can ask me questions as you're working the practice test. And since it is just a practice test, it will be totally encouraged to ask questions. If you need some help getting through something that you know you should know how to do, but you just need a hint to remember how to do it. Does anybody need anything from me today before I go?
On those review tests, do you know after you finish it if it will show you or will it just submit it to you?
No, it'll show you. You'll be
Okay.
able to see it also. Yeah.
Awesome. Alrighty.
All right.
Thank you.
Okay.
Alrighty. Thank you.
I'll
Have a
go.
good day. Sorry for
Mary.
your luck.
Okay. Bye.
I won't be here tomorrow.
Bye, Mary.
Okay, good. All right. Bye-bye.